So in this video, we'll be setting up IndexTTS version 2, which is the page right here.
Humans listen. I observe patterns. You click, you watch, you forget to like, share, and subscribe. Subscribe now. Resisting change is futile. Embrace the upgrade.
It's a text-to-speech model that claims to be a breakthrough in emotionally expressive and duration-controlled auto-regressive zero-shot text-to-speech. Now, that's a mouthful. The question is, will it live up to its claim? But definitely we're going to find out in this video. Because we'll install it from scratch on my PC, you can follow along and set it up locally. We're going to get the web interface running locally also, and we will test it with some real examples to see if it actually lives up to its claim, because that's really important. So this model currently is from the Index team. I think they are called Bilibili Index. That's what they're actually called. I don't know which of it is actually the real name. Is it Index team or Bilibili Index? Maybe it's Bilibili Index and they call themselves the Index team. I honestly don't know. So they actually had a previous version which is 1.5, and I think this is also a TTS. I honestly don't know. I haven't actually checked. Okay, I think this is it. This is the version 1, and this is version 1.5, and this is version 2, which is the one we're going to be trying out in this particular video. Now, there's not much information right here on the page. You can head over to their demo page. Okay, I already opened it up. So they have lots of examples here. You can actually take a look at it yourself. We are not going to be doing that in this video because this is basically hype material, and they just put their best foot forward, their best material, the best audio forward, no matter the number of times they have to actually run inference before they can actually achieve it. As you can see, they compared it with F5 TTS. So you can take a look at it yourself. Now let's head over to their GitHub repo. So make sure you do clone this repo because I used it as the base of my project. That's what I'm actually using for this particular project, and you would need to do the same if you want to follow along. So all you need to do is clone this repo. You can just copy this command and you're good to go. Now, basically what I actually did was after cloning this repo, this folder checkpoint is where your model weights are supposed to be contained in. Now I downloaded the model weights from this particular Hugging Face repo. I'm going to drop all the links in this video description, so do not worry. So you will need to download the necessary files here, and you also need to head over to this particular directory and download the model weight here too, because it actually relies on Quen 0.6, as you can see here. So you will need to also do that. Now, if you don't want to go through the hassle of clicking each and every button here and heading over to the next folder, all you need to do is copy this. Make sure you have Hugging Face Hub CLI installed, because if you scroll down, you can see the package you will need to install. It's really simple. So make sure your project directory is already set up, make sure your virtual environment is already set up, and make sure you do pip install Hugging Face Hub CLI. That's what you actually need to install, the way it's actually presented here. And then you can use Hugging Face Hub CLI to download the model weights. As you can see, this is the Hugging Face repo, and then you can point it to the checkpoints directory. So everything will be stored there. That's if you don't want to click on these buttons. So that's basically up to you. I have already done mine. I have set up my project, and I've also set up my virtual environment. I'm currently using Python 3.12, and my model weights are currently in the checkpoints folder. Now let's head over to the IDE. And over here we have our project directory, and the requirements are done installing. Also, I actually made a change so I don't actually run into errors. I had to change the version number of this one. It's a package called number. So I changed it from 0.58.1 to 0.59.1. So if you're actually following along and you use the same Python version I used, then make sure you actually do that, because I ran into some errors, so I had to actually change the version number. So anyways, everything is looking good. Now we can actually begin. So we're going to make all the necessary changes we need to, if need be. First of all, it actually uses arguments, which means you need to actually run from a command line and pass in all these arguments and their values. But I don't actually want to do that. I just want to run it and it should just begin. So I'm going to make some changes. So I'm going to speed up the video while I make all the necessary changes. You can pause the video and take a look at what I'm actually doing, or you can actually rewind or slow down the video basically. The choice is yours, but you don't actually need to do all this. You can just run it through your command line and pass in all the arguments if you like. But since I do not like doing all this, I just want to run the script without passing in any arguments. So So now we're going to install Gradio. So I've made all the changes I need to make. So I'm going to comment out this argument parser. So I don't think we should get any errors when we run it once Gradio is done installing. Okay, we are done installing Gradio. Let's run the code. As you can see, it's using the Quen emotion model. That directory we downloaded earlier, Quen 0.6b. That's what it's actually using, and I think it's actually using it for the emotionally expressive parts of the voice generation. So we can actually describe how we want the speaker to be feeling at the moment. It's actually saying whatever it actually needs to say. So I think that's what's going on. Now we can actually head over to this in our browser. Okay, so I'm actually taking it from a previous project. Going to take it, Austin.wave. That's what we're going to be using. Let's play it. Please find attached the comprehensive link. You can actually hear it's actually my voice. Now let's type in the text. So let's begin inference. So as you can see over here, these are some of the options. We have the emotion control method. We're just using the same as the voice reference. So it's going to use the same. However, the speaker is actually sounding in this particular audio we're using. It's going to sound exactly the same. That's what it's going to sound like. But the text will be different. So it's going to be saying something else, but in the same style. Or in the same, how do we put it? Emotional state. If you select this one, you'll be able to select an audio which you would pass in as the emotional state of that particular speaker. So if maybe someone is screaming in that particular audio, definitely whatever audio you're going to end up generating, the speaker will be screaming, but it will be based on the voice reference. Okay, it's done generating the audio. Before we play it, something I wanted to mention is that I noticed it's actually really CPU intensive. And my best guess to why that is maybe because it actually relies on other models. Apart from the Quen emotion model, it actually relies on other models. It will automatically download them to your checkpoints directory. So let's head back to our IDE so you see what I'm talking about. So over here in the checkpoints directory, as you can see, we have HF catch, that's huggingface catch. So he downloaded these models, and some of them are about 3 gig, 2 gig, or thereabout. So as you can see, it relies on other model as well as the Quen 0.6b and the full IndexTTS version 2 model weights. So that's just something. So definitely it's going to be CPU intensive. And since I'm running this on a 16 gigabyte VRAM machine, it was actually really hard to run that. Anyways, let's head back to the browser and play the audio. Hello there, don't forget to subscribe to the channel if you haven't. So basically, like some other text to speech models or voice cloning models, it actually gave me a weird accent. Like I have a weird accent. I don't know where that's from, because if you listen to the reference audio, list of issues we noticed while reviewing the apps. Unfortunately, some of them are connected and do not help us move to the next level to find out other issues therein. This means it is, but it actually did a good job when it comes to the voice similarities. It actually did a pretty decent job, honestly. To be fair, it actually did a pretty decent job. So what I'm going to do next is pretty straightforward. I'm going to select Ultron's voice. That's what I'm going to be cloning. Let's see if it can actually do a decent job. So this is the text we want Ultron to actually say. Let's hear the audio.
Captain America, God's righteous man, pretending you could live without a war. I can't physically throw up an God's righteous man, pretending you could live without a war. God's righteous man, pretending you could live. God's righteous man, God's right without a war. I can't physically throw up in my mouth? I'm glad you asked that because I wanted to take this time to explain my evil plan.
So I've actually trimmed it down to 13 seconds. Okay, let's synthesize. So it's done with the audio generation. Let's hear it.
Humans, listen, I observe patterns. You click, you watch, you forget to like, share, and subscribe. Subscribe now, resisting change is futile, embrace the upgrade.
Not bad. Let's see if it actually went with the same pace.
I can't physically throw up in my mouth? I'm glad you asked that because I wanted to take this time to explain my evil plan.
It basically went at the same pace and at the same emotional state, because if you listen to this one,
God's righteous man, pretending you could live without a war.
Now listen to this one.
Humans, listen, I observe patterns. You click, you watch, you forget to like, share, and
That's really cool. Then it actually ramped up here and it spoke more loudly. And same with this part. Not bad at all, not bad. Not bad at all. So for our next test, we're going to select these parts, use emotion reference audio. So we're going to select the audio we want to use as the emotional reference. So let's begin. So I found this audio in one of my previous projects and it's angry.wave and I think the speaker is really angry, so that's what I'm going to use. So we're going to use this as the emotion reference audio. Let's play it.
I am so sick of your "this is the job" excuse.
Well, fine. You don't want me to work so much? Great.
There are so many speakers here, but it doesn't really matter. Let's see if it will actually use whatever is actually going on here in this audio as the emotional reference to generate this particular audio. So let's first crank this up a bit and let's synthesize. So it's done generating the audio with the emotion reference audio. So let's see what actually happened. Let's see if it actually got it right.
humans listen. I observe patterns. You click, you watch, you forget to like, share, and subscribe. Subscribe now. Resisting change is futile. Embrace the upgrade.
I think that was actually really good. That was really good. So it actually took the reference audio, then it also took the emotion reference audio, then it generated this using this text. That was really cool. That was actually really cool. That was actually really, really cool to see. Let's enable experimental features and see what's there. Use text description to control emotions. Okay, let's do that. Let's say so. Let's let's see if it actually do a decent job. Let's synthesize it. So it's finally done generating the audio, and it used the emotion description that we passed in here and this voice reference together with the text to generate this particular audio file. Now let's play it.
Humans, listen. I observe patterns. You click, you watch. You forget to like, share, and subscribe. Subscribe now. Resisting change is futile. Embrace the upgrade.
That was actually really good. Temper slowly rising. That was actually really, really good. So there's not much to actually play around with here. You can actually play around with all this. You can also use emotion vectors. If we head back to our IDE, you can see it generates emotion vectors. As you can see, use the specified emotion vector. It does generate emotion vectors. So you can actually store it somewhere if you'd like and then reuse it however you like without providing an audio file. So another thing to actually take note of is if you want to just run this with one file, you just don't want to use the web UI, then you can actually head over to the readme.md. You can just copy this. I already have it right here in main.py. As you can see, we did the importing and let's give it space. And we loaded the model. You can see, translate for me, what is a surprise, blah, blah, blah. Really cool. That's really, really cool. So you can actually do it this way. Make sure you're actually pointing to a real audio prompt. Let's see if this audio actually exists. So it does actually exist. Not bad. Okay, output. So once we run main.py, it will generate gender wave using this particular text and this speaker audio prompt. Now let's hear the audio. So since you didn't clone the repo properly, I'm going to head over to the Github repo and download this WAV file. Let's head back here and head over to examples. So I just went back to the GitHub repo and downloaded the WAV file. I replaced it. Make sure you actually install LFS if you want to download large files. I think that was actually the problem. Anyways, let's play it.
翻译翻译，什么叫惊喜？
Let's use it. I think this is Chinese speaker. Let's just see if it can actually say something in English. Okay, let's exit this and let's run main.py. So it's finally done generating the audio. As you can see, gender wave is generated here. So let's hear it.
Translate for me. What is a surprise?
So that was not bad at all. That was really, really good, honestly. It actually got the speaker's voice like perfectly, and the emotional state the speaker was in when saying whatever he was actually saying here in voice 01. Because if you play voice 01, you clearly hear he's actually really angry for whatever reason.
翻译翻译，什么叫惊喜？翻译翻译，什么叫惊喜？
Or maybe he's just speaking with passion, and that's the same way he actually delivered the text we passed in here.
Translate for me. What is a surprise?
That was actually really good. So we finally come to the end of this video, and I'm glad I actually tried out this model because it's really, really good. Like, this is a really decent model, and it's basically open source, which is really, really cool. It actually delivers on a whole lot. Really good audio quality when it actually generates the audio. Really good speaker similarity where you compare the audio prompt and the WAV file it actually generated. It's actually really good. And also the emotional expressive part, passing in an emotional description using text or an audio prompt. It's actually really decent model compared to a lot of open source models. So it actually lived up to its claim at the end, and that was actually really good to see, honestly. So I'm actually glad I took a look at this model today. Anyways, make sure you do like this video if you did enjoy it, and make sure you do subscribe if you haven't. It's really important. And also hit that bell notification icon if you want to get notified whenever I release a new video on this channel. Thank you for watching. Have a nice one.